This is Honors Algebra 2 Pre-Calculus. We're doing 10.7 in Pre-Calc, which is polar coordinates. So the question on the table is, how do we convert between rectangular and polar coordinates? So x comma y and r comma theta. If we're using both coordinate systems to describe the same point, right, the same spot, in space, we're describing the exact same location, how can we convert between these two ways of expressing it? And the answer is four formulae that you already know really, really well. So if we were in normal class, if we were sitting in 209, I would say, all right, people, I want you to try and think about looking at this triangle, and I want you to come up with a formula that relates x and y and r, just x and y and r. I also want you to come up with a formula that relates theta and x and r, theta and y and r, and x and y and theta, right? And so I'd ask you to come up with these formulae. Unfortunately, we're not sitting in 209, so I'm going to have to kind of do it ahead of time, but usually what happens is I give you a couple minutes to do that on your own. So I will try to pause a little bit in the video, but you should also use the pause function on this video when I ask a question to try and figure it out on your own for a sec, okay? So the first thing I want us to do, so I'm going to slide this guy over here, okay? One, I want an equation that involves x, y, and r, right? We're going to find that in a sec, okay? Second thing I want is I want an equation that involves theta, y, and r. Third thing I want is an equation that involves theta and x and r, right? And the last thing I want is an equation that involves x and y and theta, okay? So again, I'm going to walk through these in order, and I want you to take a minute and sort of pause the video to stop and think, hey, how would I do that, right? So the first thing we're going to do is number one. We want an equation that relates x and y and r. So if you look at this, this is a triangle, right? It's x units to the left and right, it's y units up, and it's got r as a hypotenuse. This is a right triangle, and there is a way to relate the sides in a right triangle, right? So the equation I want to relate x and y and r is that x squared plus y squared equals r squared. So that's the equation we're looking for in number one, right? Now your book's going to give you these equations on page 751, but let's walk through all four of them. So for equation 2, I want to relate theta and y and r. Well, there's a system that we use to relate the angle in a right triangle to the sides, and that system is trig, and we use SOHCAHTOA as an acronym to help us remember, right? So I intentionally put so first, right? Sine of theta should be the opposite, which is y, on top of the hypotenuse, which is r, right? So one way, so that's the equation we're looking at, although the way you're normally going to see it is, let me actually see if I can squeeze this in. The way you're normally going to see it, so we have sine of theta equals y over r, but the way you're usually going to see this is solve for y, where we multiply the r over, and you're going to see it as y equals r sine of theta. So that's the way you're going to see that formula. So it's just so from SOHCAHTOA. My next equation asks me to relate theta to x and r. Well, that's the other half of this situation. It's the ka, right? It's just like sine usually goes with cosine, right? So the cosine of theta is the adjacent side, x, over the hypotenuse, which is r. So the way you're usually going to see that is x equals r cosine theta. Now, what's funny is you've actually seen these before. You've seen them in the unit circle. Where you saw them in the unit circle was that r was 1. So on the unit circle, the x on the unit circle is just cosine theta. No r cosine theta. The reason there's no r is because r is 1. So x is 1 times cosine theta. The y on the unit circle is 1 times the sine of theta, hence sine theta. And then the last one, we did SOHCAH. We're going to do TOA. So the tangent of theta is going to be y on top of x. And those four equations that I boxed, x squared plus y squared equals r squared, y equals r sine theta, y equals r cosine theta, and and tangent of theta equals y over x, those all appear on page 751 as the way that we convert between rectangular and polar or vice versa. But again, none of those are new formulae. You've seen this a bajillion times. You've been doing Pythagorean theorem since Algebra 1. You've been doing SOHCAHTOA probably since at least geometry, if not also Algebra 1, and definitely all this year. So none of these things are new, even though they're in a new context.